So for the second test, I have to check that g of f of x is also equal to x. So I would want to be doing g of 1 over 1 plus x, which means I have to take this stuff and plug it into the g function everywhere I see an x. So it's going to be 1 minus that stuff over that stuff. And on top, it would be easiest if I get a common denominator, which will be 1 plus x. So I'm going to turn this into 1 over 1 plus x, because that's still 1. And then remember, I'm subtracting, so what's going to happen is those 1s, it's going to be 1 minus 1, those 1s are going to cancel out, and so I'll have x over 1 plus x. That's all from the numerator. And on bottom I have 1 over 1 plus x. And then I'll just multiply top and bottom since I have the same denominator. Cancel, cancel, and poof, I get x. So I just showed that algebraically they are inverses because the order of the composition doesn't matter, and I still get x for both of them. So then when I look at graphically, I know that this first graph is going to have a vertical asymptote at x equals -1. It'll have a horizontal asymptote. Remember, that's based off of the degrees, so the degree on bottom is bigger, so it'll be y equals 0. I can't make it have an x-intercept, because x-intercept y would be 0, and I can't make the fraction equal 0, so there'll be no y-intercept. Let's try that again. There'll be no x-intercept for the reason I just said. I can't make y be 0, but there is a y-intercept if I make x 0. So if x is 0, I'll get 1 over 1, which is 1. And so that'll give me enough to start graphing. So I have a vertical at -1. I have a horizontal at 0. I have a y-intercept at 0, 1, which tells me up in here I'll be approaching the asymptotes. So I'm going to make a little tiny xy table, and I really need to check a number to the left of the vertical to see if I'm in either this second region or this third region. Now, of course, I'll have to erase those. And so I'm going to try just to the left of the vertical asymptote, which is -2. And if I plug that into the equation, I'll have 1 over 1 plus -2, which will be a -1. So the graph is looking like this. Now, on the second graph, I'm going to get a vertical asymptote at x equals 0. Since their degrees are the same, I'll have to use leading coefficient over leading coefficient for the horizontal, so it'll be y equals -1, because I got a -1 over a +1. And then I could set that fraction equal to 0, so if y is 0, in order for the fraction to be 0, x will have to be 1 on top. And if I let x be 0, well, that would be illegal. I can't have that happen. So now I can start to graph. I have a vertical at x equals 0. I have a horizontal at y equals -1. I have an x-intercept at 1, 0. And I would like to see what's going on over to the left of the vertical. So I'll make a little tiny mini xy table. And to the left of the vertical, I would want to try -1. And if I plug in -1, on top I'll get 2, and on bottom I'll get -1, so that would give me a -2. And so this version is looking like this. So of course I want to make sure that they are symmetric about y equals x. So I'm going to draw it in. And imagine folding it. This piece would line up on this piece, and this piece would line up on this piece, and the same in the other section.